Class doesn't meet today because of the late start, so we're going to do a little video on using Venn diagrams to find the least common multiple and the greatest common factor. So we're taking a look at these two numbers, 60 and 144. And we're going to look at greatest common factor right now. And if you remember from previous years, you either did factor trees or successive division to help us come up with the prime factorization for these numbers. So I'm just going to do 60 off to the side, and I'm going to do it with successive division, where we are dividing by prime numbers. So the first prime that I'm going to do is 60 divided by 2, which gets you to 30. And then 30 divided by 2 gets you to 15. 15 divided by 3 gets you to 5. And then 5 divided by 5 gets you to 1. You could always divide by 3 to start with, or 5. As long as you have 2 times 2 times 3 times 5 in any order, then you do have your product of primes. You're going to go ahead and do 144 as well, and then on the next screen we'll look at how we're going to place these numbers. So now we have products of primes for both the 60 and the 144 here. And you'll see that I've taken the 2 times 2 times 3 times 5, and I've written it in here. And the 3 times 3 times 2 times 2 times 2 times 2, I've written it in here. This is the 60, and this is the 144. But now as we move down toward our last Venn diagram, we're going to start to look at what's common, that intersection of the products of the primes, those prime numbers. So we have a 5 with the 60, but there's no 5 on the 144, so the 5 is going to stay on the outside, just with the 60. We do have a 3 right here, and we do have a 3 here, so that's getting shared, and we're going to put that in the center. We also have a 2 here, and then a 2 over here, so I'm going to put that in the center. And we have another 2, and I'm going to put another 2 in the center. And then over on the outside, we have some leftovers. We have a 3, a 2, and a 2. 1, 2, 3, 4, 5, 6. So I'm just double checking. I have 6 total factors for the 144, or product primes, and I have 4 for here. So what do you think the greatest common factor would be? Greatest common, right there. 3 times 2 times 2. And your GCF would be 12. If you had to find the least common multiple, what do you think you would do in that case? You would take all of the numbers and you would multiply them all together. So you would multiply your greatest common factor, which is 12, and then you would multiply it by 5 times 3 times 2 times 2, which would get you an LCM of 720. For your homework, you're going to be looking at 2 sheets. One is the greatest common factor, and the other is the least common multiple. The example that they have given here at the top is to find the GCF of 20 and 30. And you can see that they put 24 and 30. The 24 is on the left side and the 30 is on the right. Doing your prime factorizations, 24 would be 2 times 2 times 2 times 3, and 30 is 2 times 3 times 5. These are the overlapping prime numbers that both have in common, and these are the leftovers. So the greatest common factor of 24 and 30 is 6. And if you had to do the least common multiple, what do you think you would do? You would multiply that 6 by 2 times 2 times 5. Your practice problems, you have 4. 2 of them are double Venn diagrams, and one's a triple Venn diagram. I suggest that you write out your prime factorization and really take a minute to figure out where your placement is. And in this case, this might be the easiest spot to start for the greatest common factor of 18, 45, and 60. If there is a problem that has no common factors, if there's two numbers that have no common factors other than 1, there is a special term for that pair of numbers. Does anybody know what that special term is? That would be relatively prime. So you're going to do the greatest common factor, and the other sheet is the least common multiple, and we'll go over this in class when we meet again.